When we're doing Newton's laws problems, the first thing we're going to have to do in any problem is draw a free body diagram. Let's see how to do that. So here's the rules for drawing free body diagrams. First step, you have to draw the object and all the forces acting on the object. Now, drawing the object doesn't have to be an artistic thing. You can draw boxes or circles, either way. But you have to draw all the forces acting on the object. Next, you need to draw and label all the forces as vectors. So you're going to draw arrows for each force. Now, these forces need to be drawn. They need to start touching the object, and they need to point in the direction the force is acting. And the last step, draw and label the direction of the acceleration. If the object is accelerating, you're going to draw a vector somewhere near the object, not touching the object. The forces touch the object, the acceleration does not. So let's look at some examples here. So here we have a box sitting on a table, and we want to draw the free body diagram for it. So we draw our box. Pretty simple, draw a box. And then our forces that we have acting on it, well, the force of gravity acting downward, because it always acts downward, and we have the normal force acting upwards. The normal force is the force of the table pushing back up on the box. There is no acceleration because it's just sitting on a table, so we don't have to draw the acceleration vector. So let's look at the free body diagram for a box being pushed across a rough table at a constant speed. When you see something say that it's being pushed across a rough table, that means there's friction. That's just kind of a clue that there's friction. So we draw a box. The first two forces are real easy. Force of gravity going down, normal force going up, because the table is still pushing up on the box. The box is being pushed across the table, so we draw F push. And there's force of friction, which is going to go the opposite direction, so we draw that over here. We don't have any acceleration because we're moving at a constant velocity, or constant speed, but it can be helpful to draw the direction of the velocity so that you know what direction the friction is. Now what if our box is being accelerated? So we have these same four forces. We have force of gravity going down, normal force going up, force push to the right, and force of friction to the left. We now have acceleration going to the right, and so I'm drawing force push a little bit longer than the force of friction, just to show me that there's more force push than there is force of friction. Because those are not balanced, because they're not equal, that's where we get acceleration from. Now what if something's going down a hill? When things are on a hill, it's a little bit different. Force of gravity always acts straight down. It doesn't matter if it's on a hill or flat, so we can always draw that one. Normal force, recall, acts perpendicular to the surface, so we draw it pointing off this direction. And the force of friction, since we're sliding down the hill, force of friction is going to be going up the hill. And we say the acceleration is pointing down the hill. Doesn't have to be, but in this case, that's what I chose it to be. And one more, this one involves tension. So we have a box hanging from a rope. So we have our box here, and you see the rope is connected to it. The force of gravity is acting downward, and the force of tension is going to act upward along the rope. Tension always acts along the rope. It won't act in some direction the rope is not going in, because that's the force because of the rope. So we have these two forces. If it's just hanging there, there is no acceleration. We could be accelerating the box up or down by raising it or lowering it or something like that. In that case, we would draw some acceleration. But in this case, we don't have any. It's just hanging there. So, free body diagrams are going to be used to set up something called net force equations, which we will get to in another video. These net force equations will be used to solve every Newton's law problem. So every Newton's law problem, you're going to have to start off drawing a free body diagram. If you can't draw a free body diagram correctly, you're not going to be able to get a net force equation correct, and that means you're not going to get the right answer. So make sure you can draw a free body diagram in all situations, because that's the first step of every problem.